Hi, this is Chris Ashworth from FlexJet. Today we're going to be talking about a couple of terms that some may know great detail about because of the type of work you do, and others may not really understand what they mean. The first one would be accuracy, and that's how well a machine positions itself based on the command that you give it. Repeatability comes down to how, when you go back to that position, how well it gets into that position or how close it repeats that position. And these two terms, sometimes they get overlaid on top of each other, but they really require two different things. And we've got a little bit of a chart here, like when you got, if you're commanding 100, 100, the machine needs to go to that position, but when it gets there, we have ways to measure that to see if it actually got there or not. And then repeatability would be if we do that multiple times, like in most cases, we'll do the transition 3 times to see what kind of compensation tables we need to create to account for any errors in the machine. You know, both of them are important as far as the operation of the machine. I mean, accuracy is what you're looking for to get a good quality part. Repeatability is you want to repeat that. You want to have a good quality part every time you cut it. Now, the machine, as far as we step from accuracy and repeatability into straightness, like we started talking about the cantilever design versus a gantry design. They're both good. They both do certain things much better than the other. And in this case, like when you get into the cantilever, we tend to be a little more concerned with straightness and squareness than you might on a gantry, although you want to track it on both designs of machines. As far as straightness, like if you're going down your x-axis, you want to know if the y is maintaining a straight line. You don't want to see the y moving in and out as the x is traveling. And squareness, that would be as you're moving the y-axis towards x or back and forth, it's not going on a diagonal versus being a true perpendicular motion. On just about every machine tool ever made, there is some amount of error. And to get around the error, we get into using compensation tables, lasers to track the data, to create the compensation tables, ball bars. For instance, we use Renishaw ball bars to do all of our tracking after the machine's installed to check circularity and prove that, make adjustments to our tables and accordingly to get the most accurate machine we can and repeatable as well. The ball bar, we tend to use that all in several places on the machine, where the linear laser, we track for each axis individually and create a compensation table to eliminate as much error as possible. This allows us to get down to, or adjust for mechanical issues to get us down to within 2 thousandths over like a 10-foot range on the table itself. With the ball bar, as far as testing the circularity on the machine, you're trying to find out if you're cutting a true circle. If the motion itself, it follows a circular trajectory without turning into an egg shape or an oblong shape, or maybe you have a lot of backlash in your system and every time it goes across the transition, you'll get a little divot in your part, things to that effect. That's what we're tracking with the ball bar. Versus a linear laser, we're just looking for errors in position. So if we tell it to go to 5 inches, it might be 4.9999. We can put a comp table in so you get a true 5 inches out of the motion, and all of that's handled in the background. Now with our installations, we do this after the machine is installed, anchored to the floor, and in some cases, like with the cantilevers, it's better to grout the machine into position as well. And after the fact, then we go through and do like a final shot with the laser to make it as absolutely accurate as possible. As far as where the accuracy and repeatability, how truly accurate does your machine have to be? It really depends on the application. As we go from one application to the other, whether you're cutting just rubber gaskets, they might not be quite as, or I should say more compliant on the tolerances than somebody cutting titanium parts for an F-22 or other aerospace type divisions. So the requirements from one customer might be considerably different than another, where accuracy you could be within 10 thousandths and nobody's going to complain about it. In other cases, you might not, you might be holding a 1/10 of a thousandth and you still got to try to make it more accurate. We're not trying to push that limit. The machines are, if the room temperature changes you're going to lose that kind of accuracy. But overall, we're still going to stay down in that 1 to 2,000th range. Well, that gives us a little bit of a perspective of accuracy versus repeatability. We'll be following up with more of these videos and just describing some of the general stuff as we move forward. Look forward to bringing up the next topic.